All right, we're going to start talking about functions, and most of term one will be talking about quadratic functions. But before we do that, let's talk about what is a function. A function is a relationship between two variables such that each value of the first is paired with exactly one value of the second. So if we're referring to x's and y's, that means every x has only one unique y. And I'm sure in previous classes you may have talked about the vertical line test, which is a way you can determine whether a graph is a function or not. So if you take a look here at this blue parabola, the red lines are vertical lines that go through this. As long as the red lines only touch the blue graph at one point, then it is a function. If you take a look at a function like a circle, well, not a function, a graph like a circle, and this blue line goes through it, it goes through at 2 points, which means it is not a function. So let's talk specifically about quadratic functions. Quadratic function is defined as a function that can be written in the form y equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal to 0. Obviously, a cannot equal 0 because if a equals 0, then that x squared term would also be 0. And if that term goes away, then you're really left with a linear function. So a quadratic function is really a function that has an x squared in it. The graph of a quadratic function is a parabola, and we often say that that is U-shaped. It has a vertex, and the vertex is the point at which the parabola changes direction. The coordinates of the vertex are given a special name. We call them h and k. It is still an x and y, but we give it a special name so that you know that we are referring to the vertex. So we can write the quadratic function in a different form. We can say y equals a parentheses x minus h close parentheses squared plus k. There's many different types of ways that we can write the quadratic formula. The first type that I gave you at the top of the page is called standard form, and the one at the bottom of the page is called vertex form. And it's called vertex form because you can simply tell what the vertex is just by looking at the equation. Notice, however, that there's a subtraction sign in front of the h, so the h value would always be the opposite sign of what you see in the equation. In either form, if the a value is greater than 0, then the parabola opens up and your vertex is a minimum value or the smallest value of the function. And if a is less than 0, then the parabola opens down and the value of k or the vertex is a maximum value. Parabolas are symmetrical, and so therefore they have an axis of symmetry. And that is a vertical line through the vertex that separates the graph into two symmetrical parts. The equation of the axis of symmetry will always be x equals whatever the x value of the vertex is, or whatever h is. And there's lots of examples in real life where you can see parabolas, McDonald's sign, fountains, and I'll just go through these quickly so you can look. So let's see how we can graph these functions. Anytime you have a function and you have no idea what it looks like, now we know it looks like a U-shape, but let's pretend we had no idea what it looked like. The best place to start is to simply make an xy table. We now know that this y equals x squared is the parent function for the quadratics. All right, so let's pick some values for x and then solve for y. So if we said x was 0, plugged it in, 0 squared is 0, so y is 0. If we picked 1, 1 squared is 1. If we picked 2, 2 squared is 4. But we could also pick negative numbers. So negative 1 squared is negative 1 times negative 1, so that would still be positive 1. Negative 2 squared would be 4. And now let's go ahead and graph this. So 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. And make sure when you draw your parabola, I want to make sure I see two things. I want to see a rounded graph, not a pointed graph, because it's not an absolute value function. And I'd like to see arrows on either side. This right here, this blue line that I just drew in, is your axis of symmetry. So your axis of symmetry will be at x equals 0. All right, so here we see this equation is in vertex form. It now has a horizontal shift 3 units to the right. Remember, it's always the opposite sign of what you see next to the x. The easiest way to graph this is to first go ahead and plot your shift, and then use your standard table of values and graph from your shifted point. So we know that the graph would sort of look like this if it was our parent function. Because this is a shift 3 units to the right, we know that the function is going to look like this. So if we just simply put our first point at 3, 0, from this point now we can use our standard table of values to plot the other points. So if you remember from our table, we went over 1, up 1. We went over 2, up 4. We went over -1, up 1, and we went over -2, up 4. So once you plot your shifted vertex, you just use your standard table of values to plot the rest of your points. All right, this here is a shift now in the opposite direction. So our vertex now is at -3, 0. So I'm going to plot this point. Once I've plotted my shift, from this shifted vertex, I'm going to use my standard table of values. Over 1, up 1, over 2, up 4, over -1, up 1, over -2, up 4, and draw my parabola. This now I have both a horizontal and a vertical shift. So this would be 3 units to the left and 4 units up. So right there, 3 units to the left, 4 units up. Now that I've graphed this point, I'm going to use my standard table of values. Over 1, up 1, over 2, up 4, and -1, up 1, -2, up 4. All right, so now we have a vertex here at -3, 4, but I also have this negative sign outside, which is going to flip my function. So I often call this a y multiplier, because what it does is going to take your y's and it's going to multiply it by a negative number. So if I plugged in 1, I would get -1. If I plugged in 2, I would get -4. If I plugged in -1, I'd get -1, and plugged in -2, I'd get -4. So now from this shifted point, -3, up 4, I'm now going to go over 1, but now I'm going to go down 1 because my y's are multiplied by a negative. And if I go over 2, I'm going to go down 4 because my y's are multiplied by a -1.